After you have calibrated your robot with the tool, user frame and object frame and generated the toolpath in your CAM software, it's time to start IRBCAM. The first step is to select the robot, and in this example we will use the IRB 1400. After that we define the tool. We use the generic tool and enter the numbers from the calibration. The orientation of this tool, generic tool, is already at 90-degree rotation but RY, so that's the same as in our calibration. The next step is to define the user frame, and we enter the numbers from the calibration results. And here we enter the quaternion because that's what we received from the robot controller. Like that. And we see that here this quaternion is more or less equal to a minus 90-degree rotation about the z-axis, which we can also see here that the user frame has been rotated about this blue z-axis minus 90 degrees approximately relative to the base frame of the robot. After that we enter the object frame, so these are the numbers from that calibration. And the quaternion we see here that this quaternion is more or less equal to a minus 180-degree rotation about the z-axis. We can see that from this picture that the object frame is rotated approximately 180 degrees relative to the user frame. The reason why we do that is that the letters in the IRBCAM logo will be facing the camera in the video which will follow. Once we have defined the station, you can save it, and then later you can pull it much faster back up. So this calibration you only have to do it once unless you change the tool or your table setup. The next step now is to load the APT file from the CAM software. So we remember this file name 1001, import, and we can have a look at the XY plot, and here we will recognize the 2D contour that we generated in the CAM software. So I go back to the 3D graphics. The information in the APT file is only 5 axes. You have the XYZ position of the tool and an orientation which can be described by only 2 angles, while the robot has 6 degrees of freedom. So this is where IRBCAM comes into play, that it can be used to safely define the 6th degree of freedom of the robot. So we go to configure path, and if you pull this slider you can see that you can decide how the initial position will be. This can be useful, for example, to avoid twisting of cables if you have electricity and cooling to the spindle. You can use IRBCAM here to check that you have a nice initial position without any problems. You can also do wrist down here or wrist up, for example. If we now click configure, IRBCAM will check the entire path, that every single point in the 2D contour is reachable, and yeah, there's no singularity and there are no problems with large jumps in the path, etc. So if you're able to configure the path successfully in IRBCAM, you can be 100% sure that this code will run without problems on the robot. Because the last thing you want is in the middle of a machining job that the robot stops because there's an error in the code. So you want to have this extra level of verification of the toolpath. The final step now is to generate the robot code. So here we have some parameters like the weight of the tool, center of gravity, and some naming. So just click export, and I'm gonna save that to robot code, and we can have a look at this generated code. And this is for ABB robots. You can see we start with an initial move absolute joint, then there are lots of move L linear moves, and further down we also have some arc movements. Now the next step is to transfer this code to the ABB controller and start machining, which will be shown in the following video.